I would like to ask Mr. Pokorný now, who studied biology, history. He worked in the Czech Academy of Sciences. He is the director of ENKI o.p.s, public service company, and he is actively involved in protection of plants and distribution of water and creation of climates. And he's highlighting the fact that forest managers must be recognized in the shaping of climates and water supply. And he's giving lectures in many universities, and he is in charge of many projects.
Good afternoon. Can you hear me, please? Thank you for the invitation. So I will provide such a general view of what we do with water and solar energy. First, we have to realize that the sun is heating the earth by 290 degrees Celsius. And you can understand what we do actually with the solar energy on large areas. I follow up to a lecture that I had a year ago. This picture shows the circulation of water and runoff water at various stages of the European countryside as created by Scandinavians in cooperation with Professor Lippel. You see, it's some 25, 30 years ago. So the ice time has abandoned us, then forests came, and then man came colonizing the landscape, and then as the colonization grew, there was human management of crops based mostly on steppe grasses, and we have to create proper conditions, and so we cultivate soils, and there was eutrophisation of soils that was subject to solution at the time. And then people, one generation older than me, said you had a closed water circulation system, so water evaporated and there was a rainfall, like afternoon rainfall, and today we have so-called open water circulation, waiting for rainfall from the Atlantic Ocean, depending on where we are. So there is soil acidification and calcium, potassium, and magnesium depletion, and so we have problems of soil depletion because alkalic substances actually escape from soil. Sorry, I wish to interrupt you. Some technical break. We're asking Mr. Pokorný to show his presentation because we don't see his presentation on the screen. So now we have it, and so we can continue. So soil acidification. So we can look at the river basins as we have it today. There is quite unbalanced groundwater surface and the quick development of settlements, etc., and a quick runoff, water runoff. And so we should be able to create such water basins so that we do not lose the nutrients, and so we have as many green areas as possible, which consume our solar energy to make photosynthesis and create the climate, mainly. When 30 years ago, people actually were dealing with the landscape. Let's look at the picture one. There is picture chart number 1, so which is the landscape when it came here, early Middle Ages, 1,000 years ago roughly, but this happened in Africa since the beginning of the 20th century. We should be somewhere at picture number 2. As we release wastewater, as we have agriculture, we should actually return water, recycle water, and there is a futuristic version, advanced technologies inside cities. So when we started to have climate problems and problems with explaining the increase in temperatures, we have been focusing more and more on what we have been doing with solar energy. So the sun heats the planet by 290 degrees. We can measure atmosphere on the surface to see how much solar energy we receive, and then we get 180,000 terawatts. But we have only 10 terawatts in economy. This is what we sell to each other. And now the question is whether we do something with the energy, whether we change it in our neighborhoods. So let's repeat the notion how we measure energy in watts per meter. No problem today. Instruments cost €1. In full sunshine, so up to 1,000 watt is per 1 square meter, and for the operation of 1 liter of water, we consume 240 kilograms of joules. It's 0.7 kilograms of energy. So if 1 liter of water evaporates, we have 1,000 actually water vapor. So we can see it. We see energy, and energy is hidden in the water vapor, 0.7 kilowatt per square, and this capacity of one battery. And then you see vegetation actually. So you can see just the enormous flows of solar energy. And so actually it is hidden in vapor. Then what happens is condensation. So actually condensation back to water, pressure drops, and 0.7 kilowatt per hour again is released. So if we have full sunshine, and we had that today, so at noon, the intensity of solar radiation is up to 1,000 watts per 1 meter. If we have dense clouds, then the quantity of solar energy is 100, 200 watts per square meter, so 10 times less. This is the Temelín, our biggest power plant, and so we can see 2 square kilometers when the sunshine comes, so much energy coming, actually what the Temelín power plant gives in the grids. So it's interesting to know what we actually do with the energy. We have an example, a tree. We measure solar energy on a sidewalk. You can see the values. At 877 watts per square meter and 27 degrees Celsius surface temperature. Then under a tree, there is actually temperature 24 degrees lower, and radiation 10 times lower, and that's due to evaporation. 20 times 0.7 is 14, so it cools with 14 kilowatts. It's 5 equipment as we know it. This is described here. Let's see actually the landscape. We use thermal camera. We can see water, elder stands, and also water, and the dump sites, etc. You can see asphalt 49 degrees, and on this very small piece of 500 piece of countryside, we have 20 degrees difference on the surface, depending on what we offer to the sun. So if we offer a dry surface. Most of the solar energy of the 800, 900 watts warms the surface, and actually warm air is getting up. If we have water, and as most of the energy, as we can see, is transformed, and then it's rain. We are getting situation 10, 11, 12 hectares of agricultural soil per hectare day is vanishing. Today in Czech Republic we have big dry surfaces, and people who fly in aircraft know that actually they get a rising thermical trend. There is rising air, and then if we can see this on this picture, and then actually we can see that in the upper atmosphere the cloud of warm air and also humidity high. So we see forest, and next to it is a dry surface. It can be parking lot, or actually harvested the field with no clover or alpha because we don't need it. There's a dry surface, looks innocently, but it warms the air. Warm air is rising, and you have a figure that given the speed of 1 meter per second, in some 20% water saturation, the air 40 degrees actually takes away 36 liters of water from 1 liter, so it sucks in the upper direction, and we are able to measure this. This more complicated chart is just to show that if the sun shines actually on concrete surface, that most is 40 watts is changed to heat, and warm air is rising. So if the sunshine goes on vegetation, so most of the 40 watts is hidden in water vapor, and so it doesn't rise, and then we get it back as fog, etc. So we are able to measure it. Mr. Vishka showed the apocalyptic things. There is the bark beetle disaster, so 40 degrees the surface temperature, in shadow 26 degrees, but if we go to a living forest, 300 meters, let's say, we have 19 degrees Celsius temperature there. We concentrate today on increased CO2 concentration, which increases the greenhouse gas effect, and try to sort out the problems by so-called sequestrating CO2 and trying to achieve a climate neutral economy. Let's see. Here we see the sun, the earth with its atmosphere, 1300, 1400 watts per meter comes, depending on a distance to sun, and the radiative forcing, thanks to greenhouse gases that have risen since 1750. It's 1 to 3 watts per square meter, and this is due to increased concentration of CO2, methane, etc. You have some information from ITCC. You can see carbon dioxide, that the increased concentration of CO2 from 200 to 400 ppE, that is millimeters in cubic liters, caused 1 or 2 watts per square meters higher radiation back from the atmosphere. And this is the well-known charts showing the rising CO2 concentration and the climbing average temperature of the Earth. This is a correlation which is very difficult to verify empirically. What is important here is to have a table. We have air temperature, we have maximum humidity in grams of water vapor per cubic meter, and here it's calculated, it's converted to TPM. These are values comparable with what we cite in dioxide in TTP. We can see 430, we can see 20,000 TPM, and if there is a then we can see 37 in summer, or if there is only 50% humidity, we can see 15,000 ppm. Why I'm showing this? The concentration of water vapor is very changeable. It's very high in comparison with the O2, and we do not pay sufficient attention to it. At the same time, the concentration of methane is 1.5 pp. It's very low in comparison with what we do with water. The basic question is whether we influence the water vapor content and the cloud building in our countryside, in our landscape. And so Intergovernmental Panel on Climate Change report says in English the basic things, where it says that people do not influence the content of vapor in the air by what they do, but through the greenhouse gas effect. That is how the atmosphere is warming. Don't be angry with me, but you can't agree with this. And this is a key matter for us to understand what we do with climate. Can we measure a greenhouse gas effect? Here is a commercial equipment, which is a standard one. On the left-hand side, that's the measuring one, reflected solar radiation. There up measures warmth, and also there is the warmth leaving the Earth. 20 April 2020, green up to 50 meters per square meters, and reflected was 200, and about 150 watts went to the sky. It's cloudy, only 300 or 350 watts per square meter of solar energy is coming. We have about 40-50, and something flows to the atmosphere. So the clouds decide on what is happening, and we can have a look at this. So 20th of April, 21st of April, then partly cloudy, 17th of May, then fully cloudy. You can see the data. And let's take the red curve, which is the clear day on the 20th of April when fruits froze, and we see that what flows to the atmosphere is 160 liters per square meter, because sky is open, no clouds, and so we are closer to the outer space. And if it's cloudy, overcast, actually, so the flows are very low, and the tens of watts per square meter. So definitely the content of water vapor and clouds actually is about how much we get cooler to the outer space. You can see the temperatures 20th of April, when there is a clear weather, the efficient temperature is about minus 20 degrees. When there is overcast, the effective temperature of the sky is very close to that of the Earth, because the clouds actually do not let the warmth go down, and they get warm from the Earth. So now we have a measuring instrument, 20 years old, and it measures the amount of energy and transforms it to temperature. I'm aiming at the blue sky, and there is minus 17, and now I'm aiming to the cloud, and it's plus 13. From the same spot we can see that we influence the amount of warmth which we or heat that we send to the clouds. And so depending on the clouds, and so when we see the changing landscape, there is less evaporization, and there's more warmth or heat actually flowing away. And so there are more warm spots because the landscape gets overheated. I fully agree with Mr. Jandosek. This is not an attack on the farmers, but rather we want to say what we do with the landscape. If we harvest on 18,000 kilometers rapeseed oil, or rapeseed actually, so the field gets overheated, and we have actually leak of heat and it's a very, very huge number. It's like 9,000 gigawatts, like production of power plant in Czech Republic, 12 gigawatts. So it's connected with enormous flows of heat upwards. So if since the beginning of the 20th century we have had less in Eastern Africa, less and less forests, so the iceberg on the Kilimanjaro is melting because of the warm air. And so this is not difficult to measure today, but I have been trying to exploit. Let me conclude by saying that actually the farmer determines the quality of runoff water and quality of the landscape, but we must measure. And also there's actually, as we are eliminating forests, that we are no longer getting Atlantic flow across Europe to northern China. So let me look at some warning pictures. To say Greece, that used to be green landscape, now you know that this is Africa, this is not CO2, so this is no vegetation, this is where I grew, and this one is the last one. So when we actually put back functional vegetation, I fully agree that we need animals in order to improve soil fertility, and so can be the intermediate crops, clover or alfalfa, that we will get more water, more food, there will be increased biodiversity, sequestration of carbon, and employment and nutrients, etc. And that's all. Thank you very much for your attention.
Je cestou k nápravě redukce orné půdy asi, pokud je nadprodukce a její zpětné zalesnění. Já myslím, že to je dobrá ukázka.
Is the reforestation a good way how to improve the reduction of cultivatable land? I do not think it is the way. We have heard the paper of Mr. Picha. It is the way. In fact, we are losing the arable land, cultivatable land. We also should not transport daily used products over long distances. And it's not bad to slightly overproduce food. And I think having the arable land as long as possible green, then we should implement the organic matter to it. I remember time when I was a small boy, it was not possible to run over the field. Now it is possible, and you can even drive on it. We can also plant clovers and other commodities like alfalfa or lucerne. Looking to everything, I really would like to praise the different layers of wood. Then you achieve the inversion temperature, lower temperature at the bottom. Then in the crown level, they communicate with the atmosphere, and we do not lose the humidity. We need to cover the landscape green.